is the third part of this exercise. And by now you should be quite familiar with dot product and formula related to dot product. We'll look at a few more examples about applying the formula and so using dot product for solving other problems. Start with the question 9 here. It's very straightforward. And so the vector given, you must ensure that you know how to now write this in the IJK form in component form like this. Straight away you should be able to see that, right? So then by dot that, I will skip everything, just go straight to the answer. You will get a -1. The other thing is the angle between A and B. If you recall, there's this formula or definition, geometrical definitions about dot product of two vectors when when theta is actually angle between the two vectors. Right? Hope you recall that. So in this case, this is something similar to that. It means that we can use this starting from here and let the angle theta be the angle between A and B. And so we have recalculated A dot B in part A, and that's -1. Plus the magnitude of A would be -1 square time plus -1 square plus 1 square times magnitude of B. That would be 1 square plus 1 square plus 1 square and cosine theta. So cosine theta is therefore -1. And this is actually 3 square root of 3. This is also square root of 3, so the product of square root of 3 will be 3. And then when we perform some simple algebra, we get this. And so theta is clearly well, we can call a calculator to help us. Okay, cosine -1 over 3. So roughly 109. I think we'll keep it as such. We will take the one without this, without negative. Another way we can look at it is that we can take the acute angle, or you can take the acute angle theta equal to 180 degrees minus 109.47, and we can calculate that again. So we take 180 and subtract the answer. So that is 70.53. It's about all of the 70.53 degrees. So that's two ways to look about it, because this means that the A, B, they behave like this. So A here, we have B here, and so there will be two angles that you will get from the calculation. So this obtuse angle here is 109.47, whereas this acute angle is 70.53. That's all. That's what it means. Calculation. So both would give us an idea about the angle between the two vectors. Now move on to part C. So I need something. Look at the formula of this. And clearly, the projection vector of this is given as follow, and we can use this formula to calculate projection vector of A on B. So it's pretty straightforward. The projection vector A on B is pretty straightforward. Just uses A dot B, the modulus. We just want to ensure there's no negative value when you do the dot product of B with the B, and then multiply by this part is actually the unit vector, if you recall that unit vector, and so this would be -1. This would be square root of 3 times 1 over square root of 3, of course, and times B, the vector B. And the vector B is actually this here, 1, 1, 1. So if you perform all the calculations, we get, in the end, you end up with this. -3, negative, because it's modulus. I'm sorry, so that's positive, and 1 over 3. So you get a vector of 1/3, 1/3, and 1/3. And this is there's no negative because of the modulus. And finally, so this is a vector that is the projection of A on B. And finally, the length of projection of A on B is actually this part of the formula. You see, this part of the formula. And so by looking at this, so the length is therefore this part of the formula, A dot B, the modulus, over the modulus of B. And we actually have calculated this right here. Look at this, actually right here. And the outcome is actually 1 over square root of 3. And that is the length of the projection of A on B. Right? Now move on to question 11. I just want to provide some guide on how to do this. So they ask you to find the measure of angle PQR for points given as follows. So look at A, for example. So what you do is PQR. So this is what they're talking about. There's a PQR, right? 3 points in space, and you kind of form a triangle if you want to. So this is the angle they're talking about, this data. So all you need to do is find QP and find QR. So like for part A, so you sketch it and then find what that is, and find what our QR, what that is. And by using the formula QP, right, dot QR is equivalent to QP QR times cosine theta. And using this, you should be able to find your data. That's the angle between both these two angles, and you can work on the others part in this question 11. Now move on to, I hope you try this, right? Move on to one more for this part 3, or I'll do one more in the part 4 of the this exercise. Right, this question 14. Find the tetrahedron ABCD. This and so point A, and then they ask you to find the angle of DMA. So this is a combination of some vector and so on. So the M clearly is a midpoint. So M is midpoint of BC. So that's clearly is 2 plus 1. You see, as you can see here. Okay, 2 plus 1 over 2. We have done this earlier, I think. The formula that find midpoint. So you got 3 over 2, 5 over 2, and 3 over 2. That's the coordinates of M. And the part B, find the measure of angle DMA. So this provide guide on how to do this. And so if you look at DMA, this is what you're talking about, DMA. Right? So this is the angle you're talking about here. You can't see a switch color to help you visualize this better. So DEMA, and this is the angle we're talking about. If you look at here, I try to draw this again. It's A, assume that DMA in 2D. This is the angle theta we're talking about. And so with this in mind, we know that now we make sure M is the point where the two vectors animate from. So all you do, find MD, you find MA, right? And you should get 3/2, -1/2, and -3/2. Okay? And this should be halved, -3/2 and -1/2. And so using this formula again, MD dot MA is equal to the magnitude of vector MD and the magnitude of vector MA times cosine theta, and you do your stuff, and you should get theta approximately equivalent to 51.5, I think. Right. So try those, and probably you can try also question 15, and see you in the part 4 of the video, and all the best.